We are now going to build more on unit rates and make some connections with some things that we did earlier in this unit. So the I can statement for section 6.5 is I can use unit rates in equations. So we talked a little bit about algebraic equations. We've solved equations before. We also set up some relationships and did a little bit of graphing earlier in the unit. We're going to try and tie some of those things together as we get close to the end of this unit. So in the warm-up question, it says find the unit rate for each situation here. So you run 6 miles in 2 hours. 6 miles in 2 hours. Well, we'd almost naturally figure that out. So this is 6 miles on the top, 2 hours on the bottom. Let's go ahead and reduce that. 2 goes in here 3 times, 2 goes in here once. So we could say 3 miles per hour. That would be the answer on that one. And on this one, 4 presents for every 2 children. And it says in parentheses the way they want us to set this up. So this would be presents per child. So the presents are going to go on the top and the children are going to go on the bottom. So this is going to be 4 on the top, 2 on the bottom. We're going to go ahead and simplify. I'm not going to do this step right here. I'm just going to skip immediately to 2 presents per child. 2 presents per child, and that's going to be our answer on that one. Okay, now this right here is a big deal. One reason that unit rates are valuable is because they make things easy to compare. So let's write the word compare here. We made a big deal of that a couple of sections ago. One of the other reasons that unit rates are valuable is because we can easily do what's called scale the rate up or scale the rate down. And what that means is make an equivalent fraction that's bigger or make an equivalent fraction that's smaller. And scaling can be made easier by using an equation. So that's what we're going to talk about today, is we're going to talk about how we can relate unit rates and equations with the graphs that we were familiar with already. So let's take a look at this one right here. It says you can run 6 miles in 2 hours. Well, gosh, there we go. That's it right there. We've got that unit rate problem right here. And we figured out, gosh, we had a 3 on the top and a 1 on the bottom. And here's what it says. It says complete the table of values, begin with 0. I'll show you what that means in a second. Plot the points and use the unit rate to create an equation that would represent what happens in the table. So here's what we're going to do. So this person is running 6 miles in 2 hours, or in other words, they're running 3 miles in 1 hour. So let's put the hours right here, and then notice that it says start with 0. So this is going to be 0, and then we'll just go 1, 2, 3, and 4. So if you had 0 hours to run, they're not going to cover any mileage at all. That's going to be 0, 0. If we gave them 1 hour to run, if they're running 3 miles an hour, they're going to run 3 miles. If we gave them 2 hours to run, that's going to be 6 miles. That's that one that came up in the warm-up question right there and in the setup for the problem. 3 hours to run, well, that would be 9 miles because they run 3 miles for each of those 3 hours. So 3 times 3 would be 9. And if we gave them 4 hours, that would be 12 miles. Okay, let's make sure we label this right here. So this is going to be on the horizontal axis. This is like the X and this is like the Y. So this is going to be hours here and this is going to be miles here. So at 0 hours, there's 0 miles. Okay, so that's what we've got right there. And then let's do the next one. The next one is 1 hour, 3 miles. 1 hour, 3 miles would be right there. 2 hours, 6 miles. 3 hours, let me make sure I got that right. There we go. Okay, and this should be looking kind of familiar. We've seen graphs like this before. There's the 412. Okay, so I'm going to go ahead and I'm going to draw a line that connects those. And since these were making a nice straight line, we're just going to kind of continue like that. I'm going to put an arrow on the end there. And that's our graph. And we've seen things like that before. Now, the next thing we want to do, so let's double check here. We completed the table of values, started with 0, got that, plotted the points, connected them to make a line. It didn't say to do that, but that's a pretty good idea here. And then it says use the unit rate to create an equation that would represent what happens in the table. Okay, well, let's do this. Let's say it says what variable should we use in the equation? Well, we could use like h and m or x and y. It doesn't really matter. I'm going to stick with x and y at least for the time being. What usually happens, think about when you go running. Usually you run You figure out how much time you've got, and the time determines how many miles you've got. So what we're going to do here is we're going to say the mileage, okay, y represents miles, is going to be determined by how much time we have. It's going to be determined by the hours. So we're going to have an x over here, and I'm going to put an equals sign right here. Now, I want you to notice something. If we start out with 0, the number of miles that we cover is 0. If we start out with 1 hour, the number of miles we cover is 3. 2 hours, 6 miles, 3 hours, 9 miles, 4 hours, 12 miles. Well, if you take a look at that, what's the relationship between hours? Like if somebody told you, hey, this is the situation, and then they told you how many hours they had, could you tell them how many miles they were going to be able to run? Well, 0 times anything is going to be 0, and then what do we do to 1 to make it a 3? What do we do to 2 to make it a 6? What do we do to 4 to make it a 9? And 3 to make it a 9, and 4 to make it a 12. And we've got to do the same thing because it's got to be the same relationship, the same proportional relationship like we were talking about before. Well, you might notice that we could just multiply every single one of these by 3. So I'm going to put a 3 right here. So if you tell me that x is, let's just pick one right here. Let's say we pick this one, 3. If we plug in a 3 right here for the number of hours, 3 times 3 is 9. Is that how many miles we get? And it is. And you can do that with any one of these. So this right here is the correct equation. Now, if you wanted to, you could do something like this. Okay, miles are going to be equal to 3 times the number of hours. And then you don't really have to declare a variable, although it might not be a bad idea. H is going to represent hours, M is going to represent miles. You tell me how many hours you're going to run, and I'll tell you how many miles. So if you could run for 10 hours, you're going to cover about 30 miles. That's kind of the idea there. So that's the equation that we're after. So we're going to do another problem. It's the other one in the starter questions. So on this one right here, it says there are 4 presents for every 2 children. Complete the table of values, use the unit rate to create an equation, plot the points and stuff like that. So this one's a little bit backwards. You'll notice we had a table, then we had a graph, and then we had some space for the equation. We're going to do this backwards. So let's do this. On this one it says 4 presents for every 2 children. Now remember, we figured out that that was 2 presents for every 1 child. Now I'm going to slide this up. I want you to notice something. Notice that what was on the bottom of the unit rate was kind of in the x's position in the table here. So, and if you think about it, this kind of makes sense, because if you were figuring out how many presents you needed for a party or something like that, you'd want to know how many kids were going to be there so that you could figure out how many presents you needed. So here's what we're going to do. We're going to say x here and y here, and we're going to say this represents children. It's very common. It's the thing on the bottom of the unit rate. And then this is going to be presents. Okay, and just like before, we're going to start with 0 children. Well, if there are 0 children, we're not going to need any presents. If there's 1 child, remember every child gets 2 presents, so that's going to be 2 presents. 2 children would need 4 presents. Notice how that matches up with what we've got here. 3 children would need 6 presents, and 4 children would need 8 presents. Now, could we write an equation? I'm going to do this one backwards. Could we figure out the number of presents from the number of children? So if somebody told us how many children there were going to be, would they be able to figure out how many presents there were? So if we think about it, let's take a look at the relationship here. What could we do to go from the number of children to the number of presents that are required for this particular party? Well, if there are no children, we don't need any presents. If there's 1 child, we need 2 presents, 2 children, 4 presents, and so forth. So you might recognize that what we'd have to do is we'd have to multiply by 2. So if you take the number of children, double it, that tells you how many presents you need. So if we wanted to write it with an x and a y, y would represent presents. 2 would be the number that we're multiplying by, and x would be whatever this variable is right here. So either one of those is fine. I'm going to leave it like this. And then it says go ahead and graph these. So let's go ahead and graph 0, 0. Okay. Oh, and let's label this. So this would be children, and then this is going to be presents, And if there are no children, there are no presents. If there's one child, there's one present. If there are two children, there's four. Three children, there would be six presents. Four children, there would be eight, and so forth. So I'm going to go ahead and draw that line right there. So this is kind of a picture of this relationship, and this is an equation that represents this relationship, and these are a bunch of numbers organized in a table that represent that relationship. Okay, well, let's come down here, and it says use the unit rate to write an equation that would represent each situation using x and y, and state what x and y represent. So usually dollars go on the top on these. So on this particular one, it says 4 gallons of gas for $8.56. You might remember this one. So this is $8.56. This is 4 gallons. So when we did that division, we ended up with 214. And remember, that was dollars here and gallons here. So this is the unit rate. And we want to write down an equation. So we want to write down y equals something times x, and then we want to say what these equal. Well, if this is the unit rate right here, if this is how much it is per gallon, and x represents gallons, and y represents the cost, I'm going to put a $sign and cost. If we bought 1 gallon, it would be $2.14. If we bought 2 gallons, it would be, let's see, $4.28. And so forth. And if we bought $4 or 4 gallons, it would be this much. Again, I want you to notice what happens here. This is going to be 214 right here. So if I put 1 gallon right here, x represents gallons. If I put 1 gallon right here, if I times it by 214, I get a cost of $2.14. If I put 4 gallons right here, I do 4 times 214, and I get 856. So that matches up with what we have here. So this is the equation that would represent this relationship. Let's do the same thing on this one. You hike 5 miles in 8 hours. So again, miles would usually go on the top, hours would go on the bottom. So this is going to be 5/8. And again, it's a story problem. So if you wanted to do 5/8 and then mi per hour, if you want to do 5/8 mph. If you wanted to do, let's see, that's a common rational number, that's 0.625 miles per hour. Any one of those would be fine for the unit rate. And then let's think about what the equation is. So we're going to write down y equals something times x, and x here, now remember, the x usually, like we had up above, usually was the thing on the bottom. So we had child here, on this one right here, x was the hours, it was the one on the bottom. So let's think about the one, oh, and it worked here too. So gallons, x was gallons. Let's look right here. This is going to be the denominator, so this is going to be hours, and then y is going to be the other variable here, miles. Okay, so we got hours represented and we got miles represented. So this is going to be 5/8 of a mile per hour, and then we just times that by however many hours we have. So just out of curiosity, let's take on this one, and again, declaring these variables, that's an important part also. I want to just go ahead and check this and show you that this actually works. So what we think is the equation is y equals 5/8 times x, and x is the number of hours. Well, we have a specific example right here. In this particular case, in 8 hours, this person covered 5 miles. Well, watch what happens here. If we do 5/8 times 8 hours, the 8s would cancel and we'd end up with 5, and that's what we should have. Okay, so I'm hoping that you've seen this. We've done 4 examples now. Is there a quick way to determine what x and y represent by looking at the unit rate? And what I'm hoping for is that you figured this out. Miles was on top, hours was on the bottom. So hours was the x coordinate and miles was the y coordinate. So the top is going to be the y coordinate and the bottom is going to be the x coordinate. Let's see if that works right here. So we had gallons. So if that's the case, gallons should be the bottom, and gallons was the bottom. Cost, that should be the top. Okay, so it worked right there. Let's check over here. So let's see, is this what these represented? Child was on the bottom. Yep, that was X. Presence, that was on the top. And then the same thing is true of that first one that we did. Hours should be on the bottom because that's the X variable, and miles should be on the top because that's the Y variable. That's the way we set up this relationship, so we could do the table, come up with a graph, and then come up with a picture. And the equation and that sort of thing. So we're going to say this: X equals bottom label, we'll call it that, bottom label, and Y equals the top label. That's the quick way to do it. Now I've got a thought question for you. Do you know why all of these turned out to be Y equals blank times X? And the hint is, think about equivalent ratios. So we're going to put a word or a couple of words right here, but I want you to notice something. That is a unit rate right here, 5/8 of a mile per hour. This is a unit rate right here. This is a unit rate. And this is a unit rate. That's the unit rate for this problem. It shows up right here. That's the unit rate for the problem. It shows up right here. That's the unit rate for the problem. It shows up right here. And that's the unit rate for the problem, and it shows up right here. So on every single one of these, it turned out to be Y equals the unit rate times X. And that's because every one of these would be an equivalent fraction. So if we did 2 over 1, again the Y coordinate, the vertical part over the horizontal, okay, 4 over 2, 6 over 3, and let's see, 8 over 4. Every single one of these simplify to be 2 over 1. They all simplify to be 2 over 1. You can do that with every single one of them up here. So we can do 3 over 1, 6 over 2, 9 over 3, 12 over 4. Every single one of them would simplify to be 3 over 1. So they would all be equivalent ratios, equivalent fractions, equivalent rates there. Okay, let's take a look at 2 problems from the assignment. Let's look at number 1 and number 13. So on number 1, it says Spencer can ride a bike at 7 miles per hour. It wants you to write an equation, and then it wants you to write an explanation of variables. And it says up here, match each equation to a context. Hint, find the unit rate and remember where the unit or where cost usually goes. So if there's a cost in one of these problems like these guys right here, remember the dollar amount usually goes on the top. So, but this one's pretty easy. This is going to be 7 miles per hour. So this is going to be 7 miles per 1 hour. And remember, the equation is going to be set up like this. It's going to be Y equals the unit rate, so that's Y equals 7 times X. Let's see, is that one of the choices here? It is, so I'm going to go ahead and cross that off. Now, this tends to be the tough part about this. This is probably going to be very easy. The explanation of variables is a little bit more difficult. So what you're going to do is you're going to write down what X and Y represent. We talked about declaring variables in this course. So we need to say, what does X represent in this problem and what does Y represent? And a quick way to remember it is X represents the unit that's on the bottom. So X is going to represent hours and Y is going to represent miles. Now on this particular one, I just want to do a quick double check and make sure that this actually works. What if we had 1 hour? If you put 1 hour right in here, what is 7 times 1? 7 times 1 would be 7 miles, so he'd cover 7 miles in 1 hour. What if we gave him 5 hours? So this would be 7 times 5 hours. 7 times 5 would be 35. If you can go 7 miles per hour, and you get 5 hours, does that mean you'd cover 35 hours? It does. And take a look at this. If we did 7 over 1, okay, because there's the Y and there's the X, and if we did 35 over 5, that changes to 7 over 1. There's those equivalent ratios. Okay, you're going to do that all the way on the front side, and then on the back side, here they gave you, on the front they gave you a bunch of things to choose from, so you can kind of check and make sure that you did it correctly. Here there's nothing to choose from, so Sally makes $12 every 2 hours. Well, remember the cost usually goes on the top, so we're going to do 12 divided by 2, so that's going to be 6 over 1, so that's going to be $6 per 1 hour. So the equation is going to be Y equals, remember it's the unit rate times X, X and Y. Now stop and think, which one is X and which one is Y? What label would we give for the X? The label's going to be the same unit as on the bottom. So we're going to say hours here, and then Y is going to be the top, so that's going to be dollars. So if she works for 6 hours, well, let's do 4 hours. If she works for 4 hours, she's going to make 4 times 6 would be, she's going to make $24. Now on this particular one, there are two problems on the back side. I do want you to get used to graphing these and stuff like that. So on this particular one, it says make a table for 13 and 14, start with 0, 0, label the axes, all that sort of stuff. So you only have to do this for 2 of these. So let's go ahead and set this one up. I'm not going to do the whole thing. You can finish it, but we'll get you started. So again, start with 0, 0. So then go from 0 to 1 to 2 to 3 to 4. So in 0 hours, she'd make $0. In 1 hour, she'd make $6. In 2 hours, we know she'd make 12. In 3 hours, 3 times 6. 3 times 6 would be 18. In 4 hours, this would be 24, like we checked before. And then you want to make sure that you're labeling the axes here. So remember, the X here is going to be hours. The Y here is going to be dollars. And we're going to do 0, 0, 1, 6. 6 is right there. And then you just graph those and connect the line. And that's going to do it for you.